Bismillah ar-Rahman ar-Rahim. Here we have February, March 2022, P1, Pure Maths 1, A-Level Maths 9709, question number 10. The topic is circular measure. The diagram shows a circle with center A of radius 5 centimeter and a circle with center B of radius 8 centimeter. The circles touch at the points C. The circles touch at the point C so that ACB is a straight line. The tangent at the point D on the smaller circle intersects the larger circle at point E over here, and it passes through point B, which is the center of the larger circle. The requirement of part A is find the perimeter of the shaded region. So in order to find the perimeter of the shaded region, what I'm going to do, I'm going to find this length DE. I'm going to find this arc length DC and this arc length EC, so that I can easily find out the perimeter of the shaded region. Now, in order to find the arc length DC and arc length EC, obviously I need these angles. Let's say this is angle A, and let's say this is angle B. So I can use the trigonometric ratios over here, since we know the fact that we are dealing with a right angled triangle over here, and in which the hypotenuse is 8 plus 5, 13, which is AB. And since AC is the radius of the smaller circle, so AD is also the radius of the smaller circle. So the length of AD is also equal to 5. Okay, so I can say that cos theta is equals to adjacent over hypotenuse. So cos A is equals to the adjacent side would be, and I'm referring to angle A, adjacent side would be AD, and the hypotenuse is AB. So cos A is equals to 5 over 13. Therefore, angle A would be equals to cos inverse 5 over 13. And you must give your angle in radian mode, okay, because we are dealing with this chapter, complete chapter, and for that the basic requirement is that you need to put your calculator in radian mode. Cos inverse 5 over 13 would be 1.176. So angle A is actually equals to 1.176 radians. Now, as we have done the working for angle A, we don't actually need to do the same working for angle B, because we know the fact that sum of all the angles in a right angle triangle is equal to 180 degrees. In this case, we would say that angle A plus angle D plus angle B is equals to pi. Okay, instead of 180 degrees, it would be pi radians. So in order to find the value of angle B, what we can do pi minus pi over 2. Instead of 90, I can say pi over 2 radians. So angle B is equals to pi minus pi over 2 minus 1.176 radians. So pi minus pi over 2 minus 1.176, meaning 0.3948. Yes, angle B would be 0.3948 radians. Okay. Now we can easily find out the arc length DC and EC. So in order to find the arc length DC, the formula would be r theta. This is the formula for arc length. So the radius over here is 5, and the angle is 1.176 radians. So 5 multiplied by 1.176. This is 5.88. 5.88 centimeter. This is the arc length DC. Now we can easily find out the arc length of EC as well, since I know this angle 0.3948. So arc length EC would be r multiplied by theta, in which r is 8, because radius of the larger circle is 8 and the angle is 0.3948. So 8 multiplied by 0.39 48, this will be 3.1584. 3.1584 centimeter. Okay, so far we have found arc length DC and EC. Now we need to find this length DE. And for that I am erasing this working above. So since we know that we are dealing with a right angle triangle over here, in which this AB is the hypotenuse, so it must satisfy the equation of the Pythagoras theorem. We can first find the length of DB. So according to Pythagoras theorem, I can say that AB square is equals to AD square plus DB square. So AB is actually 8 plus 5, which is 13. So 13 square is equals to 5 square plus DB square. So DB square is actually equals to 169 minus 25. DB square is equals to 144. Therefore, the length of DB is 12 centimeter. But so far, we also know that the radius of the larger circle is EB. So this is supposed to be 8 centimeter. So DE would be just EB minus EB. DE would be DB minus EB, meaning 12 minus 8, which is supposed to be 4 centimeter. So the length of DE is 4 centimeter, not meter, centimeter. Okay. So the perimeter of the shaded region is supposed to be, I'm doing working with this pen, black. The perimeter of the shaded region would be, perimeter of the shaded region is equal to 5.88 plus 3.1584 plus 4. 5.88 plus 3.1584 plus 4, which is 13.03. So 13.0384. So correct to 3 significant figures. Your answer is 13.0 centimeter. 13.0 centimeter will be your final answer. This is question number 10, part A, worth 5 marks. Then we have part B. Part B says that find the area of the shaded region. So in order to find the area of the shaded region, what we want first, the area of this right angle triangle ADB, and from that we can subtract the area of the sector DAC and the area of the sector EBC. So first of all, I'm going to find out the area of the right angle triangle ADB. So for that purpose, half into base into height. This base is AD, this height is DB. So area of shaded region will be equals to area of triangle. The name of triangle is ADB minus area of sector, which sector DAC, minus area of sector EBC. All right. So area of triangle ADB would be half into base into height. So half multiplied by 5 multiplied by 12. Half multiplied by 5 multiplied by 12 minus the area of sector DAC would be half r square theta. So half multiplied by 5 square multiplied by theta, which is 1.176. Theta is 1.176 minus area of sector EBC. So half multiplied by 8 square multiplied by 0.3948 radians. So 5 multiplied by 12 divided by 2, this is 30. Then minus 5 square multiplied by 1.176 multiplied by half, this is 14.7. And then 8 square divided by 2 multiplied by 0.3948. This is 12.6336. 12.6336. So 30 minus 14.7 minus 12.6336. This will be 2.6664. So 2.67 centimeter square. Correct. Two three significant figures. This is your final answer to question number 10, part B. All right, so here we have question number 11. So it is given that a curve has equation y is equals to k multiplied by 3x minus k whole thing raised to the power minus 1 plus 3x, where k is a constant, and it is unknown. Find in terms of k the values of x for which there is a stationary point. So obviously for a stationary point, you need to keep dy over dx equals to 0. So first of all, you know that the equation of the curve is y equals k times 3x minus k whole thing raised to the power minus 1 plus 3x. So for dy over dx, it will be k multiplied by minus 1 multiplied by 3x minus k whole thing raised to the power minus 2 multiplied by the derivative of 3x minus k, which is 3, and then this 3x term will be differentiated, it will become 3. So dy over dx is supposed to be minus k multiplied by 3x minus k whole thing raised to the power minus 2, and then it is multiplied by 3 as well, so I will just write minus 3k over here. Okay, I will write minus 3k over here as a constant term, and then plus 3. So dy over dx is equals to minus 3k upon 3x minus k whole squared, and then plus 3. So for the stationary point, you need to keep dy over dx equal to 0. So minus 3k upon 3x minus k the whole thing square, minus 3k upon 3x minus k the whole thing square, plus 3 is equal to 0. So this becomes like this: 3 is equals to 3k divided by 3x minus k the whole thing square. So when 3x minus k the whole thing square is made the subject of the equation, so 3x minus k whole square is equals to 3k divided by 3k over 3. So this 3 and 3 is cancelled out. Therefore, 3x minus k whole square is equals to k. Now, after taking under root on both sides, what will happen? 3x minus k will be equals to plus minus under root of k. So what we need to do, we need to find the values of x. So make x the subject of the equation. So 3x equals k plus minus under root k. So x equals k plus minus root k over 3. This is supposed to be your final answer. These are the values of x in terms of k for which there is a stationary point. All right. Then we have the next part. The next part says that the function f has a stationary point at a stationary value at x is equals to a and is defined by fx equals 4 multiplied by 3x minus 4 whole thing raised to the power minus 1 plus 3x for x is greater than or equals to 3 over 2. Find the value of a and determine the nature of the stationary point. All right, so far what we know from part A, that the equation of the curve was y is equals to k multiplied by 3x minus k, y equals k multiplied by 3x minus k whole thing raised to the power minus 1 and then plus 3x. So if we compare it with this equation of fx, obviously we can say that k is equals to 4. So we have already uh, found the stationary values of x in terms of k in a part. So that was equals to x is equals to k plus minus root k completely over 3. Okay, so in this case k is equals to 4. So the stationary value would be, I mean the stationary values would be 4 plus minus root 4 over 3. So x equals 4 plus 2 over 3, or x equals 4 minus 2 over 3. So 4 plus 2 is 6, 6 over 3 is 2, and 4 minus 2 is 2, so x equals 2 over 3. But wait, we have a restricted domain over here. X is greater than or equals to 3 over 2. Therefore x equals 2 over 3 will be ignored. Your only answer will be x is equals to 2. So the value of a is equals to 2. Since the stationary value is in the form x is equals to a, and the stationary point we have found x is equals to 2, therefore a is equals to 2. The value of a is 2, and this is your only acceptable value of a. Now what we need to do, we need to determine the nature of the stationary point as well. And for that purpose, what we are going to do, we are going to find the second order derivative. So fx equals how much? Since we already okay, one more thing is that fx equals this thing 4 multiplied by 3x minus 4 whole thing raised to the power minus 1 plus 3x. And what we know from the earlier part, from the part a, we know that when y equals k multiplied by 3x minus k whole thing raised to the power minus 1 and then plus 3x, so dy over dx is supposed to be minus 3k multiplied by 3x minus k whole thing raised to the power minus 2 and then plus 3. So in this case, in part B, as we can see that k is taken equals to 4. So now I'm talking in terms of fx. Equation of the curve is fx. So f dash x function would be, we will just substitute k is equals to 4 into this dy over dx function into the gradient function. So minus 3 multiplied by 4 multiplied by 3x minus 4 whole thing raised to the power minus 2 and then plus 3. So this becomes minus 12 multiplied by 3x minus 4 whole thing raised to the power minus 2 and then plus 3. This is the f dash x function. Now we need the second order derivative over here. So f dash x, the second order derivative would be minus 12 multiplied by minus 2 and then 3x minus 4 whole thing raised to the power minus 3, then multiply by the derivative of 3x minus 4, and then this constant term 3 will be differentiated and it will become 0. All right, so now we can actually find a simplified form for the second order derivative. So f dash x equals minus 12 multiplied by minus 2 multiplied by 3. So this is 24 multiplied by 3. 24 multiplied by 3 is 72. Okay. So 72 multiplied by 3x minus 4 whole thing raised to the power minus 3, which is 72 divided by 3x minus 4 whole cube. So we need to put this stationary point x is equal to 2 into this in order to see what is the value. So 72 divided by 3 times 2 and then minus 4 whole cube. Sorry, 3 times 2 and then minus 4 and then whole cube. So this is 72 divided by 6 minus 4 cube. So 72 divided by 2 cube. 72 divided by 8 is 9. So since f dash x, the second order derivative is greater than 0, it is a positive value. Therefore, x is equal to 2 is a minimum point. This is supposed to be your final answer to question number 11, part B. X is equal to 2 is a minimum point. Thank you for watching and good luck for the exam.